In this section, let's take a look at tropical storms. So from this, you should be able to identify the three types of tropical cyclones, explain the three stages of how they form and what these systems need to survive. You should be able to classify tropical storms, identify the eye wall, and location of storm surges, as well as understand the hazards of hurricanes. So, in the summer and fall, the tropics are ideal to form these large rotating low pressure systems called tropical cyclones. So the season is usually late May to November. So you have hurricanes, typhoons, and cyclones, and the one thing to note is all three of these systems are the same thing. They form the same way, the only difference is where they develop. So if we take a look, you can see hurricanes form in the northern Atlantic Ocean and northern Pacific Ocean. You have cyclones forming in the southern Pacific, southern Atlantic, and Indian Oceans, and typhoons are exclusively the western Pacific Ocean. Taking a look at how they form, hurricanes need two things to survive. They need plenty of warm water and continuously rising air. So as a result, these usually only form in the tropics around the equator where you have both of these things. So as this warm water evaporates over these warmer regions, you have latent heat being stored. And then remember we said, as water condenses, it releases that latent heat. What happens is it warms the air in that higher atmosphere, and then that air continues to rise. These usually begin with an existing disturbance or as a weak low pressure system, and then as it continues to develop, it goes through three stages: the formative stage, the mature stage, and the dissipation stage, which will lead to the rise and demise of hurricanes. With the formative stage, you start with a moving tropical disturbance called a tropical depression. So these are usually when your winds are 0 to 38 miles an hour. So what happens is you have this less dense, warm, moist air that's rising, and it's going to produce a lot of clouds, a lot of rain. It's going to produce updrafts, and then even start to produce downdrafts. Remember, rising air, as it goes up, it's going to need to come back down at some point, hence the downdraft. So you have this continually rising air, and it's going to keep happening because of that latent heat that's being released and continuing to warm the air. And this constant rising air away from the surface is going to create that low pressure system at the surface. So as a result, at the surface, you're going to have more warm, moist moving air moving in from higher pressures. But again, remember, as this air tries to go from high pressure to low pressure, because of the Coriolis effect, it's going to bend to the right. This is going to create a counterclockwise rotation in the northern hemisphere. So these systems all rotate counterclockwise. During the mature stage, you have air rising and rotating, and it's going to start to kind of merge towards the center of the system. And the system's going to continue to build, and the pressure is going to continue to drop as warm, moist air feeds it. When the wind speeds start to reach higher increments, when you have greater pressure differences, you're going to have a tropical storm forming at 38 miles an hour, and then as pressure continues to fall and that difference increases, your winds are going to get faster, and once it reaches 75 miles an hour, it's officially classified as a hurricane. So then you have something unique happening. So once it reaches a hurricane, you're actually going to get something called the eye to form. And it's going to be a very calm, clear part of the hurricane. And you can see it right in the middle of the system in the picture in the top right. And your strongest winds are going to be surrounding that eye in what we call the eye wall. What happens is you have a lot of rising air on either side of the eye, and that air has to go somewhere. So what it's going to do is it's actually going to sink in the eye. And remember, as we said, sinking air leads to nicer weather. It kind of clears out the clouds in that area. So in the eye, you're actually going to have a calm. So as the hurricane passes over, if you are in the eye, you're actually going to see the sun, see blue sky, not have any rain or clouds. And then as the back half of the hurricane passes over you, you're going to get all of that miserable weather again. So this hurricane's only going to last as long as it's over warm water and stay in these warmer regions. As it starts to move over land or move into colder waters, it's going to start to break up. As you have more sinking air than rising air, the system's going to start to dissipate, break down, and start to kind of change into a normal system of rain. So as these hurricanes move from one area to another, the system can actually fluctuate in intensity and move based on the winds and pressure systems surrounding it. It's going to follow these global wind patterns, but once it turns towards the poles, it's difficult to predict. So since these storms form around the equator, they're going to follow those trade winds and actually move from east to west, which is why they come towards the United States and towards Florida. But then as they start to turn north and get to that 30-degree line, they're going to start to move into a different wind belt, and you're going to have the prevailing westerlies blowing it back offshore again, which is why a lot of systems move off the coast of New Jersey. But again, because there are so many other dynamics going on, it's really difficult to predict how and where it's going to move. This makes it difficult to issue evacuations and any type of warning because we don't exactly know what the system's going to do. And that's why you can get so many crazy maps and crazy different models showing how and where the system's going to move. As far as classifying hurricanes, we classify them based on the Saffir-Simpson hurricane wind scale. So it takes a look at wind speed and potential property damage of these hurricanes. And it ranges from tropical storm, tropical depression, and then to hurricanes, and they go categories 1 through 5. So remember, we said tropical depression is 0 to 38 miles an hour. Once the wind speed reaches 39 miles an hour, all the way up to 73, 74, it's going to be a tropical storm. And then once it reaches 74, 75 miles an hour, it's going to be a category 1. A category 5 hurricane is 156 miles an hour. So a lot of the damage associated with hurricanes comes from the winds. And again, these winds are strongest at the eye wall. So you're going to have the most damage happening at the areas that get impacted by this eye wall. In addition, you're going to have a lot of rain, flooding, and even storm surges as a result. A storm surge is when a hurricane pushes a mound of water towards the shore because of all the winds rotating in that direction. So the storm surge is going to occur on the side where the wind is blowing onshore. If we take a look at this picture, notice that you have this counterclockwise rotation. So you're going to have the winds blowing onshore on the northern end of this hurricane, so it's going to push a lot of water onshore and create a storm surge. But actually on the southern end, because the winds are moving offshore, you're not going to have nearly as much of a storm surge issue because the water will be blowing away from the coast as opposed to towards the coast. What happens is with the storm surge, it stacks up the water and really pushes it onshore, and it will impact kind of like a tsunami does, but it's a little different because it's just a giant kind of bulb or bubble of water that gets pushed towards the shore and will create massive amounts of flooding. So you have the National Hurricane Center in Miami and that tracks these systems and forecasts these systems, and they'll issue warnings 36 hours in advance to let people know what's happening and then to issue evacuations if necessary. In the event of a hurricane, if you're getting impacted by it, you want to make sure you have a lot of food and water, batteries, but if you're in an area that's going to take a direct impact, you're going to want to evacuate immediately. So we talked about wind speeds and how tornadoes can be over 200 miles an hour, while hurricanes are only 156 miles an hour in Category 5. So the question is, which is worse? Well, while tornadoes have those stronger winds, hurricanes can last for hours or even days, bringing strong winds, rain, flooding, and storm surges, so ultimately a hurricane is going to be much worse. Again, from this section, you should now be able to identify the 3 types of cyclones. You should be able to explain the 3 stages of how they form and what they need to survive. You should be able to classify these tropical storms, identify the eye wall, and where a storm surge is going to occur, as well as know some of the hazards associated with these hurricanes.